Unit 1, Lesson 7, Scale Drawings. I can explain what a scale drawing is, and I can explain what its scale means. I can use a scale drawing and its scale to find actual distances. I can use the actual distance in a scale to find scale distances. So we're going to be talking about smaller versions of bigger things, okay? So it says, here are some, what is a scale drawing? Here are some drawings of a school bus, a quarter, subway lines around Boston, Massachusetts. The first three drawings of these are scale drawings. So if you look at them, think about what they have in common. The next three drawings are not scale drawings. So it's the same thing, a school bus, a quarter, and a subway map. So if you look at them, what is a scale drawing? A scale drawing is an actual replica of another figure. So it's an actual replica. So when it's drawn to scale, meaning that each part uses the same scale factor. Running out of room. Okay, so when you look at it, you can see that if you measured the drawing and then you measured the tires on the actual bus, they should be using the same scale factor as, let's say, the door of the bus or the lights on the bus, so that it's all proportional, so that every part of the bus, it makes sense, because you have to have a model before you can make a larger version of it to make sure that it's going to work. I mean, it would be silly to make this to start with the bigger, more expensive version and miss out on kind of the key details of how it's actually going to work. Oh, goodness. There it is. All right, so let's look at sizing up a basketball court. So it says 1 centimeter equals 2 meters is the scale of this drawing. It can be expressed as 1 centimeter to 2 meters, 1 centimeter for every 2 meters. What do you think the scale tells us? So when I think about it, the scale is just telling us how much to multiply by. So the scale tells us how much we're multiplying by, or each part of the drawing by. So when you think about it, you need to think that every part is done by that same scale, so that when your drawing is accurate. You know, a lot of times we, in math and in other subjects, we just kind of draw things. We do what's called a sketch. A scale drawing is measured exactly, so it's perfect. So it's an actual representation of what is going to be there. So if you were a construction worker, or you were an architect, or you were using information to build a house, whatever it is that you're going to do, where you're taking a smaller version into a bigger version, you can figure out, well, what is it supposed to look like? Because a rough picture doesn't necessarily tell you. So we're going to continue with our basketball court, and we're going to complete the table. So again, our scale is right here. 1 centimeter equals 2 meters. So for every 1 centimeter, we have 2 meters. So I know that the scale factor is 2. But my unit also changes, and that's important to notice with scale drawings. So I'm multiplying by 2. So 28 meters is the length of the actual court. So right now it's 14 centimeters. It's going to be 28 meters when this is all over. So it takes away the need to convert measurements the way we would, the way we did in 6th grade, like inches to centimeters, and then you had to convert those centimeters into meters, and then you had to convert all sorts of other things. So you had to do multiple levels. This kind of cuts out that middleman. So every part of it, you're multiplying by 2. So I know 7.5 times 2 is 15, and it's going to be 15 meters, not centimeters. So my unit of measure changes. So again, I'm going to multiply by 2. So I have 24.8 meters. So right now I'm at centimeters. I'm going to be at meters, and that's the distance between the two hoops. So that would be this distance right here between the two hoops. So you want to make sure it's accurate, because let's say you're playing basketball in Dallas and then you go to play basketball in Boston. It needs to be fair. It needs to be the same standard court. So you have to be able to give the same exact measurements. The 3-point line to the sideline is 0.5. So I'm again multiplying by 2. And this is centimeters in my drawing, but in meters, it's going to be 1 meter. Okay? So now I'm going to work on my practice problem number 2. A blueprint for a building includes a rectangular room that measures 3 inches long and 5.5 inches wide. The scale for the blueprint says 1 inch on the blueprint is equivalent to 10 feet. In the actual building, what are the dimensions of the rectangular room? Well, I have a whole bunch of white blank space, so I'm going to start drawing pictures and pulling out that key information. So it says it's 3 inches long, 5.5 inches wide. So this is not a scale drawing because I'm just eyeballing it. I want to make sure that I put my units on, because as we move through next lesson, it's going to make a huge difference. So then my scale is right here. So 1 inch equals 10 feet. So if I'm trying to figure out what my actual dimensions are going to be, I'm going to multiply all the inches by 10, because 1 inch equals 10 feet. So 3 times 10 is going to give me 30 feet. It's a huge room. And then 5.5 times 10 is going to give me 55 feet. So I'm able to do this because it says 1 inch. If it had a different unit of measure, I would have to change what I was doing. So here we have our cool down, and we're looking at 1/2 inch equals 5 feet. So this is going to change things, because you have to think 1/2 inch equals 5 feet. So that means that 1 inch is going to equal 10 feet. So if that helps you, great. If it doesn't help you, use the 1/2. The same thing, it's talking about a river. Remember, you're using this as a drawing to draw on so that you can put your answer in Canvas. Your final directions are going to be to upload this as a PDF and to complete your cool down in Canvas. If you need more help, you're going to go on Khan Academy. If you want to hear somebody else do the lesson, Mr. Morgan does this lesson, so you can listen to his version of it and his perspective. If you want to talk to somebody else, email or call your study buddy. And if you need small group, like you understood the basketball problem, but you did not understand the rectangular room, or you understood the rectangular room, but you still don't quite understand what a scale drawing is, I need to know specifically what you need so that I can get you in the right group for small group. Okay? Have a great rest of your day.